Hey guys, welcome to CMTEQ channel. You know, if you are an electronics hobbyist, you like building things, developing, testing circuit, and so forth, and having the ability to develop PCBs at home is a very important advantage. Now in this tutorial, I'm just going to demonstrate how to quickly develop or etch a PCB at home in a semi-automated PCB etching system. So what we have in front of us here is a developer, okay, a UV box. So this is a UV light controller. So basically we have a combination of UV LED hooked together to give a particular light out, and this is just a controller. So it basically, the whole system is a UV light control box, and that is good for PCB etching. So if you see here, so if I just test in for 1 minute, okay, and then I put it on, you can see that the UV LEDs are coming on, okay, and a 1 minute timer for a 1 minute exposure. But if you are developing a PCB, you would want it to be exposed for somewhere between 2 to 4 minutes, but don't overexpose it. So now in this tutorial, I'm just going to demonstrate how to quickly develop a PCB. Let's just stop there. So I've got just a small test circuit here. It's just a power splitter that I'm going to develop. So what I'm gonna do is I'll just open it and place the printed circuit. Now to get your circuit into the tracing paper here like this, you have to do a couple of things, whether you are using KiCad or Altium Design or any other PCB layout thing. You have to do some settings to develop and print it. You have to do some settings and then print it into your tracing paper. Now this is negative printing. So basically I've inverted, since it's a black and white printing, so my tracks are now in white and the rest of the things are now in black. So I've just inverted it. And this is particularly important if your PCB material is doped, if we can use that term, in negative photoresist. So if you got a positive photoresist, then you don't have to invert your printing. But if your PCB here is painted with a negative photoresist, then you need to invert your printing. So I'm just going to open this, remove this paper, and then I'm going to lay it there. Okay, here is the PCB. I've just removed that covering paper. So I'm just going to now place it here, and you have to make sure that you don't get the light exposed to it before you place it in here. So that process needs to be done in a room where there is no light coming through. Okay, so that is then in there. So I'm now going to set up my timer. I put it on 3 minutes, and then I'm going to put it on. Okay, so you can see that the light is on. Okay, the UV LEDs are on, and the thing is now going to run for 3 minutes. So at the end of 3 minutes, I should be able to have the circuit that is on the paper now transferred into the PCB, and then we're going to develop it with a universal developer. Okay, so let's come back in 3 minutes when the timer runs out. Okay, there is 7 seconds left. It's going to be completed now. There we go. So the timer have run out. We can see that the green light came on. So now what we have to do now is to open it up and remove our PCB. Okay, so let's check our PCB. There is our PCB, and what we're going to do I'm going to remove it and I'm going to put it into a solution that is water with a universal developer. A universal developer is a chemical solution, okay? It's a mix-up of potassium and sodium. It's basically a soapy solution. So just going to put it in here like that, and then we need to brush it. Okay, now this process is quite a delicate process, but you need to do it faster and you must do it properly, because if your PCB was overexposed, then you're going to have a problem. Okay, so that is it. The PCB is done developing. Now let's see if we can zoom in here. Okay, or maybe just bring this closer. Okay, so we can see that the PCB tracks have been nicely transferred into these FR4 board using the process that we've just demonstrated. So now the next thing to do now is to then dip this whole PCB into the ferric chloride solution. So what will happen there now is all the unexposed copper will then be eaten away by the ferric chloride acid, so that the only thing that will be left on my PCB will then be the tracks that are covered with this photoresist ink, and that basically will be my circuit. Okay, so now let's now move into the next stage of our semi-automated PCB development. Okay, so we are now into the next stage of our PCB development. Now this is the ferric chloride acid solutions in this bucket. So we have the ferric chloride solution already in there, and what we have here is just a PCB shaker. So basically this arrangement here is just going to be shaking the ferric chloride solution into the bucket there while vibrating as well, and that's going to speed up the process of etching, that is of eating away the copper in on this PCB. Okay, so I'm going to open it first and then I'm going to put the PCB inside. Okay, so there is a PCB in there, and then we close it again nicely. Okay, so I'm then now going to set up a timer for the machine to run. Let's give it 15 minutes, usually 10 minutes to 15 minutes, depending on how complex your PCB is, where the copper need to be eaten away. So for this one here, 10 to 15 minutes should be okay. Okay, and also if the ferric chloride have been heated up, and that also speed up the process, but I haven't preheat the ferric chloride at this point here. So let's put it then on and let the show start. Okay, now we need to put a vibration as well. Okay, so this is going to be a rough ride, rock and roll. So as you can see in there, you can see in there as the ferric chloride is basically boiling. So that is caused by the vibration. So the vibration and the back and forth, that whole process just help the acid to eat the copper much faster. So if you don't have a system like this, what you will do is put it in a bucket and shaking it manually yourself. Okay, and then hopefully the process will be terminated on time. But if you have a bucket, but if you have a system like this, then this is an automated system. You can just sit back and let the system work for you. So I've set up in there 15 minutes, and I can see now it's about 13 minutes already left. Okay, so I'm just going to turn this video off, and then we're gonna come back when the thing is finished, and then we'll check. Okay. Okay, so we are back. The 15 minute already timed out. Now let's us open and check what's the story. Now let's just put that vibration off, and I'm going to open here. Make sure when you are opening this, you do it in a ventilated room, because you don't want to be breathing that vapor that come out of there. Even though it's not hot, but there's still going to be some vapor. Okay. Now let's find our PCB. Let's see if we can move in there. Just zoom in there. Let's find the PCB. There we go. Okay. So there is a PCB. I don't want to spoil the area here. Okay, so you can see that there is no more copper left except the copper that are in the area that are covered with photoresist material or paint, and that's then going to be our tracks. So I'm just going to take this and put it in the water. Okay, and then we're going to close here. Just take this away. Okay, so we can see, I can put my hand in there because this is just normal water. Okay, so you can see there, you can see it's just tracks and the copper being eaten away. So the next thing to do here is just to clean it up, okay, with some alcohol, and then drill the holes for the through hole component here. That is just a header. This is just a power splitter. Now this is going to be exactly the same process to develop any type of circuit. Obviously this setup is limited to how small your tracks can be, but I've tried circuit of up to 0.2.5 or 0.3 millimeter thickness and even spacing. I'm going to do tutorial on those difficult circuits in the future. So basically this is it. I'm going to clean it up and then drill the holes, and then we'll see how this small power splitter goes. Okay guys, so here is a small cutout board I've just cut from that panel that we just etched now. So we had about 4 PCBs on there. So I've cut out one and clean it up, and now I'm going to just solder the headers because it's a power splitters. So basically I'm putting any voltage I'm going to put in there, it's just going to split into two. I mean, this is a simple circuit. I know why I etched this, because I need to put it somewhere. Okay, so I'm just going to solder the headers, the smaller headers here, and then we're going to see. Okay guys, so here is the small circuit power splitter that we've just etched now. As you can see, I've soldered it, and the soldering is fine, and there is reflow, everything is working. So we have our small power splitter PCB. As you can see, you can put in power here, and then it's split on by 2 on the other side. Yeah, well, it might be a very useless PCB, but I know where I'm going to use it. So thanks again for watching, and if you've learned anything in these experiment demonstrations, and please don't forget to give it a thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. I thank you. Cheers.